Hello everyone. In this lecture, I am going to solve a assistant professor physics question paper. This is a lengthy question paper, about 125 questions were there. So I am going to solve them in parts. In this video, we are going to solve about 40 questions. So this exam was conducted in March 2022. This was conducted by KEA. Okay, then let's start solving this physics paper. So the first question is, the number of fission per second in a 100 megawatt reactor is. Here they have given 100 megawatt. This is your power. Now for a reactor, power will be equal to N by T into E. This N by T is number of fissions per second. Actually, some more information is needed here. That is energy. That energy is 200 million electron volt. Actually, they should have mentioned this also in this question. 200 million electron volt. So, if energy is 200 million electron volt, this is actually for uranium. Actually, if I rephrase this question is like this actually. In each fission of uranium-235, 200 million electron volt of energy is released. If a reactor produces 100 megawatt power, then rate of fission on it will be. This is the actual question. So if you consider uranium, then the energy released will be equal to 200 million electron volt. Power is given, which is 100 megawatt. So now I can find a number of fission per second with this formula. Now N by T will become P by E. This power is 100 into 10 raised to 6 divided by energy 200 into 10 raised to 6 EV. EV is 1.6 into 10 raised to minus 19. Now if I cancel all this, I get 1 by 2 into 1 by 1.6 into 10 raised to minus 19. This will give me 0.5 into, if I write 10 and 16 here, it will become 10 to the 19 and it will be 2 5s are 10, 2 8s are 16 and 5 5s are will be 25. 0.25 by 8 into 10 raised to 19 or 0.31 into 10 raised to 19. Now if I see the options, they have given only 10 to the power something they have given in the options. So I will try to make it in a at least number, the whole number. If I write 3.1 into 10 raised to 18, then answer will be in terms of 10 raised to 18. Option D will be the right answer. Now coming to second question. The question is, the strangeness quantum number is conserved in strong and electromagnetic interactions. Also they have given weak interactions also. Now actually strangeness in particle physics, strangeness is a property of particles expressed as quantum number for decaying of particles in strong and electromagnetic interactions only. So strangeness quantum number is conserved in strong and electromagnetic interactions only, but not in weak interactions. So here in option B, they have included weak interaction. So this is the wrong option. And in option C, they have not included strong. So this is also wrong option. Weak interaction, I told you it is not there. So option A, only strong and electromagnetic interaction is the right answer. Now moving to the third question. The force vector corresponding to potential V is equal to kr cube is given by. They have given you the value of potential where k is the constant. You have to find force. We know that force is equal to minus dV by dx. Just to differentiate it, minus d by dx of, sorry, it is dV by dr, not dV by dx. So this will be equal to minus k into 3r square. So minus 3kr square is the right answer. Now here R, vector R, it is giving the direction of the force. So your option C will be the right answer. Now fourth question. For a single particle under a central force which varies as r square, the average kinetic energy T and average potential energy V obeys the relation. They have given 4 options. These options are actually a little bit confusing, but if you know the concept, then it is very simple. Actually, as an object falls under the influence of gravity, kinetic energy and potential energy will be equal, isn't it? Now, central force means gravitational force is one of the good examples for central force, right? Gravitational force and Coulomb force. So here, kinetic energy will be equal to potential energy. So, option B will be the right answer. Fifth question. The mechanism of nuclear reaction can be understood by using. Actually, compound nucleus model is one model which describes about the mechanism of nuclear reaction. So, compound nucleus model, option C is the right answer. Moving on. Question number 6. Which is wrong in the following? They have given 4 options. We have to tell which one is the wrong statement here. See here, lead 20882 is a doubly magic number actually. It is a doubly magic number. This is the right statement. Then photoelectric cross section increases with atomic number Z for a given energy. True. This is also true. Next, a free electron cannot absorb photons. True. This is also true. Then pair production takes place at all photon energies. Actually, pair production does not take place at all photon energies. It takes place at a particular energy. So this is a wrong statement. So here the option D is the right option. Moving on to question number 7. A carbon nucleus emits a particle X and changes into nitrogen according to this equation. They have given this equation. Now the next is, we should tell what is X. By seeing this equation, you can tell that this is a beta decay, right? In beta decay, what happens? Your atomic number is increased by 1. If atomic number is increased by 1, then 1 electron should be emitted, right? So, here option C, electron is the right answer. Question number 8. The following equation is an example of. Here, helium is, there is a transition and helium becomes lithium and 1 electron and 1 antineutrino is liberated. So this is a Gamow-Teller transition where your mass number is increased by 2 and atomic number is increased by 1. So option B is the right answer. Question number 6. Magic numbers are 2, 8, 28, 50, 82, 126 and so on. So in the options, if you see after 2 and 8, 28 is not there but 50 is there. So we should not get confused here because option B also looks similar here, isn't it? See in option B, we have 2, 8, 20, 50 and 82. 20 is not a magic number. In option A, there is 2, 8, 50 and 82. So option A is the right answer. Now question number 11. The question is the contribution of Coulomb energy in the semi-empirical mass formula of a nucleus of mass number A and atomic number Z is of the form. 4 options are given. We know the semi-empirical mass formula for binding energy. This is equal to all contributions, the volume contribution, surface contribution, Coulomb contribution, symmetry and pairing. Here if you see Coulomb, here it is Z into Z minus 1. A to the minus 1 by 3. So option C is the right answer. Question number 12. The binding energy per nucleon of helium nucleus is 7 MeV and that of deuteron is 2.25 MeV. Here see, it is very simple. Binding energy, the more the binding energy, more will be the stability of the atom. Here for helium it is 7 MeV, for deuteron it is 2.25. So option B, helium nucleus is more stable, is the right answer. Question number 13. The ratio of sizes of PB 20882 and MG 2612 nuclei is approximately. See here they are asking ratio of sizes, not ratio of masses. If it is ratio of mass, then you will just divide the mass number 208 by 26 and it will be 8. And the option is there, but this is wrong. You have to carefully read the question. Here they are asking ratio of sizes. Ratio of sizes means you have to keep radii ratio in mind. So we have radii is directly proportional to cube root of the mass number. And they are asking us the ratio, isn't it? So ratio of PB and mg will be equal to cube root of 208 by cube root of 26. So this will be equal to, for 208 it will be approximately 6 and for 26 it will be approximately 3 and your answer will be 2. So option B is the right answer. Moving to question number 14. The ground state of deuteron is a mixture of. Actually, ground state of deuteron, it is a mixture of 3s1 and 3d1. Here 96% of 3s1 will be there and 4% of 3d1 will be there. So option A, add mixture of 3s1 and 3d1 state is the right answer. Moving on, question number 15. According to the shell model, the ground state spin parity assignment for oxygen 15-8 nucleus is. It is actually a even and odd parity. So it will be -half. Option A will be the right answer. Question number 16. Atomic mass number of an element is 232 and its atomic number is 90. This exhibits alpha and beta radioactivity. If the stable end product is lead 20882, the number of alpha and beta particles emitted before the end product results is. Here they are telling that lead 208 and this is 82. This is the stable end product they are telling. So 232, I think it will be thorium, I think. And this will be 90. So there is a decay and lead is formed. Now they are asking how many alpha particles and how many beta particles are released here. Alpha particles means it is very simple. See, number of alpha particles will be equal to A minus A dash upon 4. If this is our atomic mass A and this is our atomic mass A dash, then it will be 232 minus 202 by 4. It will be 6. So 6 alpha particles are liberated. Now for number of beta particles. How many number of beta particles will be liberated means 2 times number of alpha particles minus original atomic number plus end product atomic number. This is the formula to find the number of beta particles. So 2 into number of alpha particles released are 6 minus the original atomic number is 90 plus the end product atomic number is 82. So this will be equal to 4. So number of alpha particles released are 6 and number of beta particles are 4. Alpha should be 6 and beta should be 4. Option C is the right answer. Next question. The reaction positron plus electron is decaying into U plus pi minus. Actually, I did not understand what is U plus. In this question paper, they have given U plus a few times. I actually don't know. But anyway, one thing I can say is electron and positrons are leptons, right? So we will have lepton number 1 and 1 here. So total lepton number will be equal to 2 in left hand side. In right hand side, this is a pion, right? Pion is not a lepton, it is a meson. So for a meson, lepton number will be 0. Here it will be 0. Anyway, whatever this is, our LHS is 2 and RHS will be 0 plus if this will be 1 also, this is a forbidden only. So I thought that because of lepton number, this reaction is forbidden. So the violation of law of conservation of lepton number, option D. Question number 18. From meson field theory, the potential energy of interaction between two nucleus is proportional to. 4 options are given. See, if one doesn't know much about meson field theory also, what I thought is, in potential energy, numerator will be whatever, but denominator will not be r square or r cube. Denominator will always be r, isn't it? So, this option B and C is not possible here. So, from option A and B, I thought that this is very much familiar. E raised to minus mu r by r, not minus mu r square. So I thought that option C is the right answer. Actually, talking about meson field theory, Yukawa gave meson field theory in 1935. He gave this potential also, E raised to minus mu r by r. Here mu is mass of the particle and r is the radial distance to the particle. So option C is the right answer. Moving on to question number 19. In a simple cubic lattice, D100, D110, D11 is DNKL represents the interplanar spacings. Is here what they have done is they have given interplanar distance with Miller indices. Now they want us to find the interplanar spacing in terms of numbers. So what you do for simple cubic lattice, what is D HKL? It will be A by square root of h square plus k square plus L square. So for D100, it will be 1 by square root of 1 square plus 0 plus 0. This will be 1. Similarly, for D110, it will be 1 by square root of 1 square plus 1 square plus 0. It will be 1 by root 2. And for D111, it will be 1 by square root of 1 square plus 1 square plus 1 square. It will be 1 by root 3. So in terms of numbers, it is 1 is to 1 by root 2 is to 1 by root 3. But this is not there anywhere in the options. So we need to simplify and put it in the simpler form. To simpler form, what you do? You take LCM of root 2 and root 3. It will become root 6. And then you simplify. This will be root 6 into, here you multiply by root 6 and here you multiply by root 6. It will be root 3 is to root 2. So this is the right option, right answer. Root 6 is to root 3 is to root 2. Option D is the right answer. Next, question number 20. A copper wire is stretched to make it 0.5% longer. The percentage change in its electrical resistance if the volume remains same is. Now we know that resistance, it depends on length and area of the conductor. But what we have to notice here is that they are talking about volume, not about area. If you think about this formula, your answer is going to be 100% wrong. So here they are telling that volume is constant. So you multiply and divide this by L so that you get R is proportional to L square by V. Now you see they are telling that 0.5% longer they have made that wire. So you can find the percentage change here now. It will be L square. So for percentage change, what you do? You take the power in the left hand side and write it like this, isn't it? This is the change in the length. So 2 into 0.5%. So it is 100. So this will be equal to 1 into 100 or 100. So option D is the right answer. Next question. A solar cell has a short circuit current of 50 milliamps and open circuit voltage of 0.7 volts under full illumination. The maximum power delivered by the cell of fill factor 0.8 is. So there is a formula to find the power delivered in a semiconductor or in a solar cell. So that is equal to maximum power is equal to fill factor into the current in the solar cell and the open circuit voltage in the solar cell. So this fill factor is 0.8 into current is 50 milliamps. So minus 3 will come and voltage is 0.7. If you multiply 8 5s are 44, 4 7s are 28, it will be 28 into 10 raised to minus 3 or 0.028 watts. So option B is the right answer. Then moving on for question number 22nd. For a close packed BCC structure of hard spheres, the lattice constant A is related to the sphere of radian r as. There are 4 options. You don't get confused. We need to write and find out. Here for BCC structure, interatomic distance is root 3 by 2 into A. And what about the radius? Radius is always equal to A upon 2, right? So this will become root 3 by 4 into A. But here in LHS only A is there every time. So we will have A is equal to R, here 4 upon root 3. So A is equal to 4R upon root 3. Option B is the right answer. Next question. The nature of bonding in solid organ is covalent, van der Waals, metallic, ionic. See, actually argon is a inert gas. It has low melting point and boiling point. In solid form also it should be held together with weak force, right? So van der Waals force is the weakest force. So option B, van der Waals force of attraction should be the right answer. Question number 24. Einstein's theory of specific heat concludes that at lower temperatures, the specific heat remains constant, drops linearly with increase in temperature, drops linearly with decrease in temperature, drops exponentially with decrease in temperature. Einstein's theory of specific heat, it could not explain the experimentally observed low temperature specific heat of solids. In experiment, the specific heat was decreasing exponentially with decrease in temperature. While in Einstein's theory, it concluded that at lower temperature, it drops linearly with a decrease in temperature. That's why we give more importance to Debye theory at lower temperatures, because Debye theory shows that the specific heat drops exponentially with a decrease in temperature. So according to Einstein's theory, that's the reason why it failed at low temperature also. The specific heat drops linearly with a decrease in temperature. Next question. For a Fermi gas of n particles in 3 dimensions, the Fermi energy is proportional to. Now Fermi energy is equal to h cross square kf square upon 2m, where kf is the wave vector. In 1D, the value of kf is different, in 2D it is different, and in 3D it is different. For 3D, kf is equal to 3 pi square n whole to the 1 by 3. So for Fermi energy, if I substitute h cross square into 3 pi square n whole to the 2 by 3, it will become upon 2m. So Fermi energy is proportional to n to the power 2 by 3. So option B is the right answer. Next question. The dispersion relation of phonons in a solid is given by. The velocity of the phonons at large wavelength is. They have given one equation. This is a dispersion relation of phonons actually, and we have to find the velocity of phonons at large wavelength. So what you do? Velocity of phonons means you have to find the group velocity. What is the method of finding group velocity? We differentiate, isn't it? d omega k by dk. So for that we have to find omega k first. Here omega square k is equal to omega naught square into 3 minus cos kxa. Instead of cos kx, I am going to use series expansion of cos x. What is the series expansion of cos x? It is cos x is equal to 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial and so on. Here I am going to take only 2. So I am going to write it like this. 3 minus, in place of cos kxa, I am going to use the series and write 1 minus kxa by 2 factorial. 2 into 1 is 1 and this will be whole square minus 1 minus kya whole square by 2 minus 1 minus kza whole square by 2. So this will become omega naught square 3 minus 3 minus, if I take a square outside, then actually k is equal to kx plus ky plus kz, the wave vector. This will become kx square plus ky square plus kz square divided by 2. So omega square k is equal to omega naught square. This will be 0 and here it will become plus a square into k square by 2, or omega k will become omega naught into a into k by root 2. Now if I differentiate it to find the group velocity, I get d by dk omega naught a k by root 2. Omega naught and a are constants. K will become 1 because we are differentiating it with respect to k, and root 2 will be remaining. So omega naught a by root 2 is the right option. Option B is the right option. Next question. In BCS model of superconductivity, the dependence of critical temperature Tc on isotope mass is, according to BCS theory, critical temperature decreases with increase in mass. Therefore, the critical temperature should be inversely proportional to mass, and therefore it is option B. The right answer is option B. Next question. For an intrinsic semiconductor at 300 Kelvin, number of protons is given, mobility of electron is given, and mobility of holes is given. You have to find the conductivity of the sample in mho per meter. For a semiconductor, the conductivity is equal to Ne into mu E plus mu N, the mobility of electron and hole. So I will write as mu P. So conductivity will be equal to, number of electrons will be equal to number of protons, isn't it? So it is 2. 2 into 10 to the 19. The mobility of electron is given as 0.39 and for proton it is given as 0.19. So conductivity will be equal to 2 into 10 to the power 19 into 0.58 into 1.6 into 10 raised to minus 19, the charge of the electron. So conductivity will become around 1.856. This will be cancelled. So this is nearly equal to 1.92. So option A is the right answer. Next question. An N-type semiconductor is, this is a very confusing question actually. It can be, see, this option is obviously you will say wrong. This also you will say it is wrong because it is a N-type semiconductor. It is most likely that you say that it is negatively charged, but this is also wrong. Actually, the charge carriers, the major charge carriers are electrons in N-type semiconductor. But as a whole, that material is not negatively charged, isn't it? It is electrically neutral. So option D is the right option. Next, which of the following phases of liquid crystalline state is characterized by both positional and orientational order? In nematic phase, there is no orientation, but position is there in order. So this is wrong. Then in cholesteric phase, actually it is chiral. What happens there is molecules are spiral or in the helical shape. So you call that they are chiral. So this is also not possible. In smectic phase, the liquid crystalline state is characterized by both positional and orientational order. So option C will be the right answer. Next question. Germanium having a forbidden gap of 0.72 eV is irradiated with monochromatic radiation. The wavelength required that would be sufficient to create an electron hole pair will be. Now they have given us the energy gap, which is 0.72 eV. They are telling us to find the wavelength. We know that E is equals to hc by lambda, and because we are talking about the EV thing, so hc by E into lambda. These are all constants. If you substitute all the values of Planck's constant and speed of light and electron, then you get a constant 1240. It's better to remember this number. But in this condition, your wavelength will be in nanometers always. So energy will be equal to 1240 by wavelength. That only we have to find, isn't it? So here I get the wavelength and energy given is 0.72. So if I divide, I get 1722 nanometer. But here in options, everything is in angstroms, right? So 1722, probably there will be 0 here. So it will be in angstroms. So which is the nearest one is this 17250, 17220. So this is the right option. Option C. Next question. The solutions to the differential equation. One differential equation is given. You have to find the solution and then you have to tell that the solution belongs to family of which type of curves. Is it hyperbola, circle, straight line or parabola? So you use this variable separable form for this equation by y plus 1. So here you take y plus 1 in the left hand side and here you take dx. Integrate it both sides. You get integral y plus 1 dy is equal to minus integral x dx. Split it, you get y square by 2 plus you get y. This is equal to minus x square by 2. So y square by 2 plus x square by 2 is equal to c minus y. So I thought that this is the equation for circles. So option B is the right answer. See, if I am making a mistake anywhere, because I am solving this question paper by myself, because no one gave the key answers till now. So I was also struggling. That's why I solved this paper. If I have made mistakes anywhere, please feel free to write in the comment section. I'll be glad if I have made any mistake. I'll be glad to correct my mistakes. Okay, next question. The value of square root of I plus square root of minus I is. This is little scary actually. But if I write it like this, it becomes very easy. Minus I whole to the power half. Actually, what is the I square? I square is minus 1, right? So I will become square root of minus 1. So in place of I will write minus 1. This minus 1 I can write it as minus 1 to the power half again. So minus 1 to the power half plus minus 1 to the power half. So whatever it is, it will be 1 plus 1 because all even numbers of minuses are there everywhere. So it will be 2. Option B should be the right answer. Next question. The average of function f of x is equal to sin x in the interval 0, pi is. 4 options are given. See, to find the average, what we do is, we write it like this. Integral for a function sin x by pi we write into dx. Now integrate it, you get minus cos x by pi. The limits are given 0 to pi. So you write it here 0 to pi. This will be equal to minus cos pi minus cos 0 by pi. Cos pi will be minus 1 and cos 0 will be minus 1. by pi. This will be equal to minus 2, minus into minus will be plus 2 by pi will be the right answer. Option C will be the right answer. Next question. The equation d square y by dx square plus 1 by x into dy by dx plus 1 minus n square by x square into y is equal to 0 is the... Actually, this is a Bessel's differential equation. If you have here some 1 minus n square or something like that for y, then that is a Bessel's differential equation format. So option C is the right answer. Next question. Sij and Aij represent a symmetric and antisymmetric real valued tensor respectively in 3 dimensions. The number of independent components of Sij and Aij are respectively. Actually, there is a short trick for this. There is a formula to find the number of independent components. That is n into n plus 1 by 2. N is number of dimensions. Because they are telling that both symmetric and antisymmetric real valued tensors, they are belonging to 3 dimensions. That's why you can use 3 for both. So 3 into 3 plus 1 by 2 will be 4 3s are 12, 12 by 2. It will be 6 independent components. So option D will be the right answer. Question number 39. Suppose refractive index n is given as n is equal to a plus b by lambda square, where a and b are constants, lambda is wavelength, then dimensions of b is same as that of. See, n is a constant. Anyway, refractive index will not have any dimension. A is a constant. Remaining is b by lambda square. So b will be having the dimensions of lambda square. Now, what is the dimension of length? What is the dimension of wavelength? It is L. So what will be the dimension of B? It will be L square. And what is L square? It is area, isn't it? So option A is the right answer. Next question. The order of error in the Simpson's rule for numerical integration with a step size h is, it is h raised to 4. So option A is the right answer. Okay friends, I tried to solve the question paper. Next part of the questions I will post in the next lecture. It will be the part 2 lecture of this playlist. I hope this helped you. Please let me know if there are any more doubts or if I had made mistakes in the comment section. Thank you.